So next presenter is Mira Peter, and will present on the threshold performances of online tutorials in the learning of threshold concepts. Thank you.
Thank you for having me here. It's a great pleasure to be here. Today I will share with you some pilot data from which are part of the project that has been running on for a year and a half now, looking into threshold concepts across 4 academic disciplines, but I will focus on one of them. So what are threshold concepts? According to threshold concepts theory, which was formalized by Mayer and Land in 2003, in each academic disciplines there are special concepts, so-called threshold concepts, which once mastered or grasped can reveal new and previously inaccessible, unseen ways of thinking about a discipline. Oh, it's not clicking? I'll take the next off. So according to threshold concept theory, these threshold concepts are transformative in the sense that we are what we know. So some of you think of yourselves as being psychologists, philosophers, even maybe engineers. They're irreversible in the sense they're hard to unlearn. Like you cannot unlearn to ride a bike or become illiterate all of a sudden. They're integrative. They cohere key aspects of a subject. They're also bounded. They serve a very limited and specific purpose. But they are also troublesome. They may appear alien, counterintuitive, they're difficult to learn, and they're places where students usually get stuck. So in this study, before that, one can draw a parallel between threshold concept theory and phase transition theory. So if you look down on the bottom left, you can see a pattern, autosynchrony or syncopation, and that would correspond to a state of students' knowledge before they even encountered threshold concepts. And on the top right, where you have a different pattern, that would correspond to the pattern of students' knowledge once they have grasped threshold concepts. In between, you have this region of instability and uncertainty, which threshold concept theory refers to as liminal space. Or in their words, learning is a messy journey back and forth across conceptual terrain, full of recursiveness and oscillations. So in the study that we did, we focused, the one I'm talking about, we focused on first-year electrical engineering students. And the challenge for the lecturer was, he has observed over the many generations that have been teaching this course, that students failed to learn a particular threshold concept. And in this case, I will be talking about Thevenin's theorem. For those who know a little bit about electrical engineering, Thevenin's theorem is actually called Thevenin's equivalent voltage and resistance theorem. What is this theorem about? Well, you can have a complex circuit that consists of a lot of elements that can be both in parallel and in series. And when you apply this Thevenin's theorem, you can reduce it and simplify it to this, into a very simple series circuit. For example, in real life, it would look like something like this. A very complex circuit that can be reduced to this, and then you can easily calculate your resistances and voltages. So, given the challenge of students not grasping threshold concepts, the lecturer developed two strategies to help them learn. The first one was to use new affordances of technology by developing online tutorials to enhance students' learning. You can think of it as meta-affordances. This is the term that your colleague has coined, Paul Treffner has coined this, and this meta-affordances would be really like affordances of the affordances, higher order affordances, and we can talk about that later. The second strategy that the lecturer developed was the use of new hands-on perception action assessment technique for learning, IFACTs. And IFAT stands for Immediate Feedback Assessment Technique. Some of you may know it as scratches. In the case you don't know what scratches are, maybe you play lotto. And I'll show you the actual scratches card. So this is an actual card that was used, that students used to do their quiz exam. It has spaces for 10 questions. The maximum number of marks that the student can get is 5. And the student will get 5 marks if they get the correct answer marked by a star on go 1. If they don't get it from the first go, like in this case on number 3, so they scratch this one, there's nothing, they scratch another one, here's a star, they score 2 points. If they get it out of 3 goes, 1 point, and everything else after that they get 0 points. The point behind this is this system is used for students in tutorials and labs to learn, where they can learn through trial and error. So give me just a bit of water. But also gives the lecturer an insight as to what the problem students have and what are their misconceptions. Why are they choosing particular answers instead of the correct ones? So that was one strategy. The second one, as I mentioned, was the development of online tutorials. And this emerged from a couple of years of us working with this lecturer and students, doing some interviews and surveys with students, where students ask for lots and lots of examples in different contexts in order to learn. And if you think about it, why are they asking for that? Well, they're asking because they're really trying to figure out what the invariances are behind this particular concept. So over the 10 weeks during our summer break, we had a PhD student who worked with this, and 2 lecturers, and a colleague of mine from education, and we helped them develop the online tutorials. So, in the olden days, in addition to weekly lectures and 3-hour labs with hands-on labs, students would come to one tutorial session, which was about 2 hours long, and they would be given 4 or 5 questions. They would work on their own. If they get stuck, they raise their hand. The lecturer comes over, helps them. If there's plenty of people who are getting stuck on the same question, then they work out the example on the board. And this is the future. So this is online tutorials, and as you can see, there are 12 sections in the tutorials. Up to section 8, and including section 8, is the analog part. And to the right, 9 to 12 is digital. We're going to concentrate on this part. And here on number 4, section number 4, is the Thevenin. So there are questions and problems for students to solve related to Thevenin's theorem. And there are 2 sections. One is on current flow, and the other one is Kirchhoff's laws, which are prerequisite, as the lecturer says, I quote, for students to even start to understand Thevenin's theorem. So they have to master those before they can even start working with Thevenin. And this is my data, so I try to pass graphs, right? And I started current flow and I flunked. This is a typical problem. So this would be a Thevenin problem that the students have to solve. They have 4 multiple choice options that they can tick, but that's not good enough because they may be guessing. So in addition to ticking a correct answer, they have to give a reasoning as to why they chose that answer. And at any time during their work, they can go and use resource links to anywhere in on the internet. And the links we try to create them such that they're related to the question they're trying to solve. So what are the affordances of these tutorials? As I said, there are multiple examples in different contexts, which would provide in our reasoning students with multiple options to explore infinite information. Randoms come to students at random. Questions come to students at random, which kind of creates a chaotic and uncertain environment. Students must pass a section before they go on to the next one. And the way to pass is that they have to give 5 correct answers in a row. They must give reason, as I mentioned before, so there are no free lunches. And there is no limit or penalty on where, when, with whom they work on these questions, or the number of errors or mistakes they can make during this work. So they have freedom to act and freedom to proceed as suits them the best. So if you're thinking about affordances as perceivable possibilities for action, students can choose to do different things in addition to doing their tutorials. They can get information, help, guidance during the lab time. This was available to them to engage in a discussion on intranet, so-called Moodle. They can go and review questions that they have already done in the sections that they have finished. They can opt out of providing research data, and we couldn't use all students' data for analysis. And they can choose, they don't have to, but they can choose to finish everything and eventually get about 10% of the final grade by finishing all 12 sections on the tutorials. And these are the data. These data were downloaded from the web on the midnight before the final exam. Each line represents a student. On the horizontal axis are different sections up to 8, right? These are the ones that are of interest to us. And on the vertical axis is the number of attempts within a section, and that includes both correct and incorrect answers. Now, if you take a look, here's the easy section graphs, right? And what you see is that the majority of students actually takes very few attempts to pass that section, right? It's easy peasy. And then comes more complex stuff, and all of a sudden you see that there are certain people who are still chugging along, taking it seriously, and taking very few attempts to give correct answers. But then there are some that get 120, 140 attempts. That's like just banging through the tutorial questions, trying to get 5 correct answers in a row by chance. Now, how efficient that is, we can only think of it. And so that's across each section. This is time-wise. So on the horizontal axis is the 16 weeks of the semester. On the vertical axis, the number of correct answers. Each color represents a student. Some of them will overlap. But what we find really interesting, and that is something that we probably all know that students do, is majority of them will cram right before the quiz, they'll cram before the quiz, and they'll cram before the exam. But there is a number of students who actually chug along consistently across as they go, and they never stop. And that is interesting. I mean, we all already kind of suspected that that's what's happening, but we have never seen it for real. All right, so that's what students did. How did they fare? Before I show you the results, this is just, so these are the IFADs for quiz 1 that covered sections 1 through 4. Students had 10 questions, 5 marks each, and questions 5, 9, and 10 were explicitly Thevenin related questions. And this is how they fared. When we're doing the analysis, we divided students into 2 groups. The blue ones are the ones who have done all 4 sections. The red ones are the ones who have not done all 4 sections of the tutorial. And as you can see, the ones who worked hard scored significantly better than those who did not. Now, for the final exam, they used just the regular multiple choice questions with the addition of that written answer as to why did you choose this option. It was not done on IFAD's card, it was just a paper exam. And there were no specific, just exclusive Thevenin questions. But all 20 questions that were in the exam had something to do with Thevenin. So we couldn't analyze individual questions, we had to look at the overall results. And this is what happened. On the top graph, is the group of students who have not completed all 8 sections of or 8 sections that belong to the analog part. And the bottom ones are the ones who have. Looking at their means, you see that those who worked hard, on average, yes, 1 minute, hey, geez. All right, so those who have worked hard, they scored better, significantly better than those who didn't. Another kind of analysis that we did was, so until this year, students went through the usual old-fashioned tutorials. So we wanted to compare if the online tutorials made any difference in student learning. And when we compared students' achievement on quiz 1, so this is only the first 4 sections, there was no difference in how well students did. But when we compared them how they did on the final exam, there was a significant difference for this year's students who have used tutorials relative to the ones who used just traditional ones. And we did also a survey with students, and as you can see, we had 88 students who finished surveys. Most of them, on each of these, we asked them, so what do you like about, is there anything that you like, what you like about the tutorials? They liked it, that there was many examples, immediate feedback, they could do it in their own time, it was faster, they knew what they were doing. They had a variety of questions, they could get lots of practice, they were efficient because they could do it at their own pace. And there were some things that they didn't like the links were not very good. They were too general. So what were the lessons for the lecture? Obviously there was a need to create more specific links related to particular questions, to include more informative hints when students get stuck, to get even more questions, and better organized online communication. Students really wanted to have either lecture or tutors or both to interact with them on discussion groups, and the better use of answer explanations. And in some, we think that our data point to the fact that online tutorials provide real opportunities for exploring multimodal information and for learning, that they provide affordances that can be perceived and acted upon, and they are well suited to individual learning styles and can provide for shifts in students' understanding. Thank you.
Thank you, Mira, for a nice presentation. There's time only for
Open for questions.
2 small questions, please.
Hello. I like your talk very much. But I was wondering about the difference in shape distribution from last year to this year. Does it mean that you're now sort of catering for some students better than, what does this, because it's no longer a normal distribution, is it?
I'll take you back. It is this one that you're looking at, yeah. Well, I find this interesting because what you see now is almost a bimodal distribution. There are students who have or are very close to mastery. There is still a bulk of them who haven't mastered it, and they would correspond to these guys. But what it seems to us is that these online tutorials provided opportunity to a small group of students to actually learn better. All right?
Any
Any
small
more?
question, please? So, thank you, Mira.
Thank you.